So good morning everyone, my name is Renz Adrian Vibatzar and I'm going to share the topic of power and energy in electric circuit. So objectives: to derive a mathematical equation to calculate the energy and power in electric circuit involving power, potential difference in volt and current in ampere. So what is power? Power is a measure of how rapidly work is done. Power is the rate at which electrical energy is converted in an electric circuit. And in electric circuits, power is a function of both voltage and current. So electrical power is calculated as power is equals to voltage times current. Power is exactly equal to the current multiplied by voltage. There is no extra constant proportionality. The unit of the measurement for power is the watt. Three equations for powers in circuits that are collectively known as Watt's law are the following. P, or the power, equals current times voltage. The second is the power equals current squared times resistance. And the third and the last one is power equals voltage squared over resistance. We can use Ohm's law to show that the power equals voltage times current is equivalent to power equals current squared times resistance, and P equals voltage squared over resistance. So here are examples of electric power travel. The first example is the series. As you can see in the pictures, where the battery is connected to the two bulbs, the power represents here is equal current, which explains that there is only one current or one flow of energy connected to the two bulbs. In the second example, the parallel, or also known as the constant current, have the different process, which is the power is being contributed at the same time and flows directly together from different direction, goes to the first bulb, and same thing or process happens to the second and the last bulb. Power and energy in electric circuits. Kilowatt per hour. 1 kilowatt is 1000 watt, or equivalently 1000 joules per second. Similarly, an hour is 3600 seconds. Combining these results, we see that a kilowatt per hour is equal to 3.6 million joules of energy. 1 kilowatt per hour equals 1000 joules per second times 3600 seconds is equals to 3.6 times 10 to the power of 6 joules. So, power and energy in electric circuit. How can we use this in our daily lives? Power and energy in electric circuits are so useful in our daily life. It is applicable when you are trying to have less electric bills. Knowing about this topic will give you knowledge on how much electricity can your appliances consume. In this way, you will be aware of the gadgets or appliances that you are using, which is making your electric bills much bigger. The second is you can identify the bills if that you are paying is valid and is right, based on how much electricity or power you consume, whether you are paying it on the exact and right amount. I'm going to show you some mathematical equations on how to solve power and energy in electric circuit. First So the first example that we have is what power is dissipated in a 69 ohms resistor if the current is 1.136 ampere. So we have the value of our resistance or resistor. So R is equals to 69 ohms and I or the current equals 1.136 ampere. So as in the question, we are looking for the power. So we were going to solve for P. The equation that we're going to use is the P is equals I squared times R. So we have to look for the I squared. The value of I is P is equals I 1.136 ampere squared times the value of our resistance, which is the 69 ohms, we will have the result of 89 watts. So in the question, the answer is what is the power dissipated in 69 ohms resistor if the current is 1.136 ampere. So the answer is 89 watts. So for the question number 2, what power is dissipated by an electric kettle that draw 8 amperes of current from the 200 volt supply? So we have the given of for the ampere, I equals 8 ampere and V for volt equals 240 volts. So we are looking for the power. We are going to use the formula of P is equals I times V. So we have the value of I, the 8 amperes times 240 volts, which is the value of our V. So we will have the result of 1.9 1920. The next example is what is the resistance of a 16 watts 240 mini submersible pump of an aquarium. So we are looking for the resistance, so it means we're going to use the formula or the equation of P equals V squared over R. Since we are looking for the resistance or the R, we are going to derive this one because it is the missing. So it will result to R is equals to V squared over power. We have the value of the V squared or the volt, which is the 240 volt squared over the power or the watts, which is the 16 watts, and we will have a result of 3600 ohms. So This example is connected from the previous example, which is what is the resistance of a 16 watts 240 volt mini submersible pump of an aquarium. So the question here is, what would be the power output if the mini submersible pump was plugged into the US mains of 110 volt? Since we are looking for the power, we will going to use the formula of P is equals to V squared over R. The value of our V squared here is the 110 volts squared, and the resistance from our previous example was 3600 ohms. So we will going to have the result of 3.36 watt. This example, the current through a remote controlled drone is 266 ampere. The battery used is 24 volt. How much is supplied by a 24 volt battery in 3 seconds? So we have the given of 266 ampere, 24 volt battery, and 3 seconds. We are going to use the formula of P is equals to E over T. So we have to derive the E and able to find it. We're going to use the formula of E is equals P times T. Since we don't have the value of our P yet, we're going to solve for it. We're going to use the formula of P is equals I times V, which is 266 ampere times 24 volt. Going to have the value of P is equals 6,384. So the next step is we're going to solve for E. So now we are going to solve for E, and the value of our time is 3 seconds. We have the formula again. The formula that we're going to use is E is equals to P times T. So we have now the value of our P, which is the E is equals 6,384 times the time, which is the 3 seconds. We will going to have the result of E is equals 19,152 joules. That is my learning on how to solve mathematical equations on power and energy in electrical circuits. I hope you learned something. Goodbye.